invite Srimati Subhalakshmi, Deputy Director, ISTRAC, Bangalore.
Ladies and gentlemen, good afternoon to all of you. My colleague, Mr. Sudhir, has taken you through a very fine presentation giving the wide spectrum of activities that ISRO can offer to the industries, both on-board space-based and ground-based. Intelligent electronics, the new frontier securing our land and space, a very apt and prudent theme selected by IESA. I am from Space Department, but I am going to present to you about ground system, that is radars that are developed by ISRO for ISRO's use as well as for nations' use like India Meteorological Department and other agencies. So I am going to talk to you about tracking and weather radars. So the topics covered are operational radars made by Radar Development Area, ISTRAC, ISRO. Then ongoing projects which are being carried out with industry support. Then future radars planned with industry. So, precision tracking radars are needed in the launch pad. Prior to every launch, we need tracking radars for range safety measurements, which will give you vital information for evaluating the performance of the launch vehicle and also to estimate the preliminary orbit. And in the launch pad, we also need wind profiler radars to give the wind information like velocity and the profile of troposphere and lower stratosphere below 25 kilometers, and these parameters are used by the Met Department for decision making. And we also need Doppler weather radars in the launch pad, which can give weather information beyond 250 kilometers for pre-launch operations. Now coming to ground-based radars, Radar Development Area is an entity of ISRO Telemetry Tracking and Command Network, ISTRAC, which is located in Peenya, Bangalore, and it is involved in the design, development, operationalization and of ground-based radar systems for ISRO's program and also for the national requirements like IMD and other user agencies in the area of weather. Now, RDA can perform the state-of-the-art radar system configuration based on user requirements and also data analysis, weather data analysis, system realization with industry support, upgradation, and also R&D for new systems. And it can also provide technology transfer and technical guidance to Indian industry to realize these radar systems for ISRO and other agencies. So coming to Doppler weather radars, they are mostly pulsed radars. They detect the motion of rain droplets, and they also detect the intensity of precipitation during rain, and they provide images of rainfall intensity by measuring the echo. So one example of a Doppler weather radar with a radome is shown. So we have Doppler weather radars in Sriharikota, and we also developed S-band Mark II polarimetric Doppler weather radars by technology transfer with Bell for IMD and ISRO. that is northeast SAC in Cherrapunji. And some 2 more S-band radars are located in Gopalpur and Cochin. And we have C-band polarimetric Doppler weather radar at TERLS, BSSC, Trivandrum. And we have also one X-band polarimetric DWR at National Atmospheric Research Laboratory in Gadangi, Tirupati, which is also an ISRO center dedicated to atmospheric research. Now I'm showing you the 6 radars that are located: C-band in Trivandrum, S-band in Cherrapunji, where the highest rainfall is received, and S-band DWR in Sriharikota, which is primarily used for supporting our launch activities, which I told in the first slide, and S-band DWR at Gopalpur, because in the east coast there is lot of cyclone and heavy rain activities are happening every year. And there is one in NARL, Gadangi, which is dedicated to atmospheric research. And one more S-band DWR is in Cochin, which is being used by IMD. Now coming to tracking radars, there also we have operational radars in C-band and S-band in SHAR and TERLS. And TERLS is where we have the rocket launching for sounding rockets. And these are established with industry support. And PCMC radar, of course, it is there in SDSC, Sriharikota. And we also have new generation precision tracking radars, which is also established through industry support. Now coming to wind profiler radars, we have MST radar in Gadangi, Tirupati, operating at 53 megahertz. We have BHF wind profiler radar at SHAR, operating at 49 megahertz. And we have also established a UHF wind profiler radar operating at 430 megahertz, which is scalable. It is installed in ISTRAC, Bangalore. Now these are the photographs of the tracking radars and the MST radar, which is already operational in various parts like Sriharikota and Gadangi. And this is the photograph of the UHF wind profiler radar installed on the rooftop at ISTRAC, which is operational since 1 year. It can give wind profile till 10 kilometers, and it will be very useful for studying the atmospheric parameters and wind parameters, and it can be scaled up. This also has been established with the support of industry. Now there are various subsystems which are used in radars, which can be supplied by the industry. Some of them I have mentioned, like antennas, transmitters, then TR modules, then solid state modulators, then receivers, automatic gain and phase compensated receivers, then FPGAs, DSP, signal processing, digital receivers, then signal processing for processors, algorithms for pulse compression, FFT, and what a wide range of activities that are going into the radar subsystems that can be realized by industry, and the design and analysis simulation can be given, guidance can be given by radar development area. And coming to, this is the typical specifications of a C-band radar, DWR, which is operating at 5 gigahertz. And various weather data products are required. So after the radar is operational, the imageries have to be generated, which give the reflectivity and horizontal, vertical reflectivity, velocity, differential reflectivity, then spectrum width. All weather parameters have to be processed and displayed as imageries. So this is a sample imagery that cyclone, all the cyclones which occurred last year, like Titli, Fetai, Fani, and all these cyclones were captured by our radars across the length and breadth of the country. So this is Fetai observation, Fetai cyclone captured by the radar in Sriharikota. So this is a kind of images we give that will tell whether the cyclone is moving towards north or south, what is the reflectivity, what is the velocity in which it is moving. All these products have to be made from the radar data. This is also a very important and challenging activity for the completion of the radar. And as I told you, during the severe floods that occurred in Kerala last year, this has appeared in the story of the week. ISRO Doppler weather radars located in Trivandrum and Cochin, they captured the flood, and it was providing support for the rescue operation. And these radars are operated 24/7, and we cannot afford to have any downtime for the weather radars, because weather information is very crucial and very demanding, and we cannot take any lenience or any delay as far as weather information is concerned. So the reliability of these radars had to be very high. They cannot fail. They should have sufficient redundancy, and they have to operate 24/7. Now coming to ongoing projects, we have successfully completed the upgradation of magnetron-based X-band DWR at NARL to SSPA based, that is solid state power amplifier based. That is the state of the art thing in radars now. Everybody is moving on to SSPA because of the compactness and other advantages. So ISTRAC is developing SSPA based C and X-band DWRs through industry, and this is a tower based state of the art design which will be deployed for national use. So I'm briefly giving the specifications of SSPA based Doppler weather radar. This is also having coverage beyond 250 kilometers, and the power is also very high. So it's a challenging task to develop such a complex radar, but industries are capable of developing this through our guidance. Now coming to new projects, debris tracking radars and multiple satellite telemetry system. These are the two futuristic projects that we are handling. So in order to establish end-to-end capability to detect and track space objects and to safeguard our national space assets, that is our satellites, one project has been formed called NETRA, Network for Space Object Tracking and Analyzing. There is lot of debris threat now. Nowadays, the number of satellites and debris is very high, that space is very crowded. It is more crowded in certain orbits like geostationary orbits. So there is always a threat that a debris will come and hit our satellites, and our satellites can go bad. So in order to protect our national assets like satellites and even space stations, even our human space program and all, debris should not be the cause for any damage or any threat. So debris tracking radars are gaining importance worldwide. So ISRO also has taken the step to build sufficient tracking capability by establishing debris tracking radars and optical telescopes, and also to establish mechanisms for space situational awareness, analysis, control and mitigation. So, and this way we can collaborate with other spacefaring nations for sharing this tracking data, because space is common for every nation. So if we have some useful information regarding the debris, and if we share with other nations, it is like international cooperation. So the project will elevate ISRO as a participant or as a partner in global efforts in SSA information exchange by sharing observational data on resident space objects. This is called resident space objects. So, as part of this debris tracking Netra project, a radar is proposed with capability to track 10 centimeter object at 2000 kilometer altitude, and towards this we need Indian industry's support to develop such a complex and very advanced radar. So these are the photographs of existing debris detection radars. As told by my previous speaker, only 3 countries have the expertise in building these kind of radars: US, Russia and Europe. So they are highly complex and advanced radars which can detect debris and predict in what is the size of the debris, in what direction it is moving, with what velocity it is moving, how can we mitigate it. There is a lot of hardware, software, tracking and analysis involved in this. So this is a very complex and challenging project which ISRO has taken up. Now coming to the specifications of these kind of debris tracking, debris detection radars, these are the specifications of the available tracking radars in various bands, and most of them, some of them are in L band, some of them are in X band, some of them are using phased array, some of them are using parabolic dish. So it is there in various configurations, and we are also trying to build a state-of-the-art and complex radar towards this. Now there is another project that is being proposed and it is planned with industry support, that is multiple satellite telemetry system. So as you know, in ISTRAC, our tracking station, we are using conventional single parabolic reflector antenna based ground stations for telemetry tracking and commanding of satellites in LEO and MEO orbits. There are many low Earth orbiting satellites, remote sensing satellites and science missions. So many of them are coming up in large numbers. So this reflector based antenna and telemetry system is dedicated to single satellite, and at a given instant of time it can track one satellite, and visibility comes when it comes above that particular station. So since the number of satellites are going to increase exponentially in the future, we have to move on to electronic beam steering and digital beam formation techniques and phased array radars to track these satellites. So this multiple satellite telemetry system is conceived, and it is planned with many capabilities such as simultaneous downlink communication from multiple satellites. As many as 200 satellites it can track with electronic steering, and it can track any satellite in any location at any direction in the sky by adopting state-of-the-art technology to cater to the large number of future satellites which are going to be built by ISRO. So this is also an advanced and challenging project which will be realized with industry support. So I am listing out some of the industry partners. This is not an exhaustive list. Many of the partners are in the pipeline, and we are also talking to many vendors. So this is only a gist of the list of vendors who had partnered with us for the development of various tracking and weather radars, and we are also thankful to this Indian industry for having for their contribution in various forms, in various hardware and various subsystems we have realized with their help. So this is one of the support which we have sought with industry. And coming to some specific activity, we have developed TR modules with Astro Microwave, and we have also developed SSPA based DWRs with data patterns, and we have also taken the services of Logic Fruit technologies and wavelet technologies. and we have some more partners coming up in the area of digital receivers and RF receivers. So we are thankful to this industry. So with this, I have just given a picture of what ISTRAC radar development area is doing, what they have done, what they are presently doing, and what are the future projects which are envisaged, and what are the support we can have from industry. Thank you for your patient listening.
Thank you, madam.